Okay, so we will go over the problem, the assignment today, okay? And then we will look at one of your assignments and see what kind of common mistakes that you guys are making again and again. So we want to try to correct that, okay? So let's remind ourselves what the problem was. The problem is that we want to do a word search, right? So we are given two files, the puzzle.txt, which contains the puzzle, right? Every row is a character representation of the row, right? And then we want to search all the birds in the words file, right? Every line is a bird. So like before, we always try to model the problem, right? We know that anytime we have this kind of grid, we can model it as a list of list, right? So let's start doing that. So let me just create the files here. So I have birds.txt. I know that some of you guys put .text.py. That's not necessary because we're just creating a text file here. Okay, no need to call that as with the .py extension. Okay, .py is for Python code itself. This is just a plain text file. Okay, so let's go ahead and copy that. Just all right, save that. And the other file that we have is the words file. So I'm going to copy the words, create a new file. Oh, why did I type this? Puzzle. Okay, copy the words file. So the first thing I need to do is create my main method. First thing I will ask is the input for the file, right? So this is the puzzle file name. So we said, okay, please enter puzzle file name. Okay, so we get the puzzle file name. We also need the words file name. Okay, so we have the words file name. So now we have the file names. We want to load from our file, right? So we have a file like this, right? So we want to read the file. So from our previous lesson, we know how to read from a file, right? So let's create a method or a function that reads a file. Okay, the file content, what will return is a list of lists, right? Each list would contain the characters in the puzzle. Okay, so I'm going to take in the file name and I'll write this with class with open file name mode equal to read text, right? And encoding I'll specify as UTF-8, right? As I'll just give it F for file, doesn't matter what the variable name is, right? So now list this file object also like supports the iterator, right? So I can just say file F for F or line in F. That's going to give me every line in this, right? So I need to return the list of lists. So let me just create a temporary variable here. Say I'll call this file content. Okay, we want to return as a list of lists, so I'll create a list here. So for every line that I read in the file, I will convert that line. First of all, I need to strip out the the new line character, right? If there's anything, because remember from the previous lesson that there's always a new line when we do a read from the file, right? Either using read line or this method of iterating. So first let's strip out the line. Then once I have a string, the string itself is, I can use the iteration on the string, right? Because we know that string is also like a list. We can do loop through it. And we also looked at the list function itself that will take in any iterator and convert that to a list, right? So if I do list of that string, that'll break it into a list of character arrays. So this is how it will look. So a file has a bunch of words, right? There's always a new line at the end, right? So when we do for line in F, right? When we do that, every line, it's going to give us this line, right? So we did line.strip, right? That'll strip it out. Then we call list on it, right? We pass that to the list constructor. Basically, it's going to take that string, which is going to have whatever here, and for every character in that string, let's make this, let's say we have cat, okay? So this is what we get after we strip out this guy, right? And we pass it to the list constructor. What is going to give us is a list. So what this guy will return will be a list, right? Because it's a list. It takes a iterator and creates a list. So every character in this list, character in the string will be put into each element, like so, okay? So now we can iterate over it more easily, right? So we have a row, right, in our puzzle. So let's go and append that list to our puzzle, right? Because puzzle is going to contain, sorry, wrong one. So we'll just append that row, right, into a file content. Okay, so file content has a list of lists. Now that's it. That's all we need to do. Now return the file content. Okay, clear on this? Any question? All right, so let's create the puzzle. So puzzle would be read file and the puzzle file name, right? And the words would be read file words file name. Okay, similarly, I'm also getting the words like a list of list, okay? But I know that I can easily convert that words a list into a string by using the join method to create a string, right? I have one method and I can use it for both, and one function to do both. Okay, so now so puzzle looks like a list of lists, right? So let's go back. New one. So what we have now is a puzzle that is a list. Every line is a list of characters, right? A, Z, whatever, L, whatever we have in the file, right? We don't care about the length because our file had all the lines have same length, right? So we don't have to worry about it. So this is how it looks. Okay, so you have to understand this before you can move on to next. Okay, this is what we have. We have a list Like there's the first starting list, which is our puzzle, which contains items that are list itself, and within it, each item is a character. Okay, that part you guys understand? Okay, so now that is our model. That's how we, so everything that we're going to program is we're going to program against this model. Okay, so so the first thing we had to do was we needed to print this, right? Let's print this. So let's write a function to print this. Print puzzle. Okay, it's going to take in the puzzle that we read. All right, so we need to iterate over the list, right? So for row in puzzle, okay, that's gonna, a row is going to be a list, right? Now we just need to iterate over this row for character in row. Okay, you know this. Okay, so I'm just going to print this, print the character, and I'll put a space. Okay, so this is, I'm printing every character. This is the row, these are all the values in that row. Okay, now I don't want to go to a new line because print always prints a new line, right? So I don't want to print a new line, so what do? I put end character to be not a new line but nothing. So once I'm printed one row, I need to make sure that I go to the next line, right? So this part here, this block here is for the inner for loop, right? I don't want to put a print in my inner for loop because I don't want to, that means I'll be putting a new line for every character. I only want to put it, the new line, after my row is printed, right? Do you understand? So let's print this. Print puzzle. Let's run this. Let's create a main, call the main method. All right, so it prints like that. Okay, this is our puzzle. Understand so far? Now we need to search for all the words, right? One by one. So for each word, we need to search our puzzle, right? So let's go back to our puzzle. All right, so our puzzle has a bunch of words, right? Doesn't matter what letters it is, I'm just putting this thing. Okay. Okay, doesn't matter. Okay, so our strategy is going to be, we're going to go through every character and we're going to compare it with our word to see from this person. Let's say for example, I picked this one. Okay, this is the character I'm looking at right now. When I'm just going to go through this list, right, puzzle. So I'm just going to go left to right, up and down. For each character, I'm going to see if my word that I'm looking for, right, whether it's this way, that way, that way, or that way, right, or that way, or that way, or that way. Okay, I know my each words. Let's say for example, if it is a cat, doesn't matter what word it is, I know this one has length of 3, right? So if I am at this position, it has some row and column. I need to make sure that I have enough space to the right if I want to search for that word cat to the right. So I need to have at least 2 other space if I'm going to search for a word that has length 3, right? And I also make sure that I don't want to go beyond what the width of my puzzle is, right? Because if I index into something that is bigger than the list, I'm going to get an exception, right? So I can't do that. It's going to blow up my program. So that's the idea. So we're going to go through every single character. For each character, we're going to look for right, left, top, down, right? Get all the characters and see if it equals to our word. That's what our algorithm going to do. Okay, that is important. We need to. This is our plan of attack. We need to go through every single character for each word. We're going to see in all 8 directions whether we have enough space to construct a word that is the same length as my word. If it is, I'm going to check if those characters are equal to my word. Make sense? Alright, so what do we need? First, what do I need to do? What's the first thing I need to do? I'm going to say for each of the words that I have in my words list. Okay, so word is basically every row in my words, right? Every word in my words. I'm going to go through. I need to go through all the characters in my puzzle, right? Left, right, top, bottom, right? I'm going to go starting here. I'm going to go one by one, every character, and look in the direction. Okay, so I need to go one by one for all the characters. How can I do that?
Use 2 for loops and
Yes.
have one for the length of the puzzle.
Yeah. So let me create a
and then
width,
one.
right? Let's calculate the width. So we know we need 4 loops, 2 for loops. So width is length of the puzzle first row. I don't care what row it is, as long as I pick one row, because all the rows I know are same width, right? Same length. So this is my width. My height is how many rows I have, which is the length of the puzzle itself, because puzzle contains list of rows, right? So now I have height, width and height. So if I want to go row wise, I'll say for.
You put a colon instead of a equal sign when you assigned height.
Yeah, thank you. So I will say for row in, what do I need to say here? Range, right? Range of width or height. What is row going to represent?
Height.
Height, right? Alright, same with the column. Column is the width. So for column in range width. Okay, so now I have a row and column. Now I can access that character at that position in my in the puzzle, right? So character is puzzle at row and column, right? That's how we get all the characters in the puzzle, right? So I would only need to start searching. So now I have the character, right? Some character. I'm going through all of them one by one. Say I have a character. I need to first check if my character starts with that character in my word, right? So let's create a define a function for that. Well, yeah, let's create a function. It's even though it's simple. So let's say is starting character same, character and my word. Now remember, word, I had it as a list of characters, right? So I will just return c equal to word at 0. Okay, Krishna, you don't need to type everything. Just focus on what I'm saying, the main logic, because I have given you all the solutions. Okay, so if you really want the solution, after every assignment I put the solution up, so solution is there. Okay, you can go through the solution later, but right now I want you to focus on the main logic of what we are doing. Okay, so I'm getting the first character in the word, and I'm comparing with the character I'm passing in, right? I got the character here. That's going to tell me if it's the starting character same. So I will call this character to be more descriptive. Okay, so this is going to return me true only if these two things are true, I mean same. Another thing to note is that whenever we are comparing using this double equal, both of these, whatever we are comparing, the two sides has to have the same type. We can only compare like an integer with an integer, or a string with a string, or a list with a list. And more specifically, the list has to contain the same type, like a list of string or list of int. Then only it makes sense, right? I wouldn't compare a string with a list. That doesn't make sense, right? So you have to compare the same types. Okay, string with a string, or here I have a character, right? It's really in Python it's a string itself. I mean a character. So I'm comparing a string with a string. Okay. So I'm gonna say if is starting character same character, and what else do I pass here? Word, right?
Word.
Okay.
Word.
So if it's same, then I can start doing my thingy, my main checking. So let's start by checking if I have. So if we go back to our thing, where is it? So let's start checking the right side. Okay, to see if we have enough space to be equal to the word length. So we have to make sure that we have enough space that we can go to the right to grab all the characters that are equal to the length of the word that we are focusing on right now. So let's write a method for that. Okay, so I'll call this has enough uh, has enough space or something. Has enough space to write. Is that a good? What's a good function name? What can I name this? Let's see. What did I name this? My mind is not working today. I call this can. Okay, can word fit. Okay, so I'm gonna say can word fit to write. I'm gonna pass in the word. I'm gonna pass in the row and column. Okay, and I'll pass in the width and the height. So in order for me to determine whether the word can fit to the right, do I need all these parameters? I'm looking to the right.
No, you only need the height. Wait, no, you only need the width.
I only need the width. Okay, I don't need the height. What about this row and column?
You don't need the row.
Yeah, I don't need the row. I don't care what basically I don't care. I don't care where I'm this way. All I'm care is this way, because I'm only comparing whether I have enough to the right. So I don't care if I'm in this row or this row or this row. Okay, makes sense. So I don't need the row. Okay, so how can I see it? Can word fit to the right? So length of the word, right? That's how I know how big the word is. Length of the word has to be less than or equal to the remaining space that I have left, right? So how can I calculate the remaining space? It's going to be width minus the column. So this is the remaining space. So let's name it remaining is width minus column. So remember, row and column are zero based, right? So here, if I name this, if I put these, so I'm getting the row and column. So 0, 1, 2, 3, 4, 5. Okay. So suppose I'm here, I'm 2, right? So my column is 2, and my width of the word is 3. Word width is 3. Now the width of the matrix or the puzzle is what? Right now I have it 6, right? So what did I say? 6 minus 2, which gives me 4. Okay, so it gives me 4, which is correct. So the width of the puzzle minus whatever the column that I'm in, that's going to tell me what's the size that is remaining that I can search in. Okay, as long as this, so it's giving me width minus column gave me 4, which is correct, right? As long as this thing is bigger than or equal to this word width, then I'm good, right? So this function seems right? So I just need to return this thing. So the length of the word has to be less than or equal to remaining space, remaining items. Just call it remaining. Okay, does that make sense? So this is going to tell me whether I have enough space to the right. Okay, now I need to get the actual content that is to the right? Now let me say get characters to right. Get yeah, so I will, let's say, what do I need to pass in if I'm creating a function like this? So I want to get the characters from the puzzle at that position. So obviously I need the row and column, right? I need the puzzle. What else do I need?
The word.
Okay, I need the word. Okay, since I already have the word, I can just pass in the word, right? So I will only call this function if this function returns true. So does that mean I need to check if I can fit the word again in here? What do you think? So I'm going to call this if, what did I call this? No, can word fit right?
If you call it in the main, then you have to give it a value, or you have to call it again in the next function.
No, my question was, do I need to call this here? Do I need to call get characters to the right function? Do I need to call this can word fit to the right in here? Do I need to do that? Because I'm already calling it here, right?
No.
No, right? I only call this function if word can fit to the right? So if word can fit to the right, I will say get characters to the right. Okay, puzzle, row, column, and word. So this will be characters to right, or let's call this puzzle word. Okay, so how can we implement this thing? What do I need to do?
For I in like the range, for I in range length of the word.
Length of the word?
Yeah.
Okay.
You have to have I had a matrix in mind before I started it. So I had
Why
an
do you want
empty
a matrix?
matrix.
You
I had
mean a,
an
you mean
empty
a list?
matrix. Empty matrix.
You mean a list, right?
Yeah, let's say.
Okay, so I'll say puzzle word. Okay. Now what?
If wait, no. Matrix dot append the crossword row and then the column.
Okay, let me ask you a question. What is I going to be right now?
The like it's going to check.
No, right here. What is I?
It's to check
No,
from
what
0
what is the
to
value for I right now?
0.
So do I need to start from 0?
No.
I have to start from the column, right?
Yeah.
So let's change this. So I need to go from column. That's my starting index. And what is the end index? So let's go back
The
here.
width. The width.
Isn't it the column plus the length of?
Yeah. So I don't need to go all the way to the width, right? I'm starting at the column, or I just need to go all the way same length as the width. So the same length as the word. That's how many steps I need to take to make sure. Say if we go back to our diagram, I'm here. Okay, I need to step in this example. I need to go all the way to the end, but if I had no, actually even in this one, I don't need to go all the way to the end. What do I need to go? I just only need to go 3 steps from here, right? This is already the first one, second one, and third one. So if this is column, what is this? This is how far I need to go, right? So what is this? How can I get this?
Row.
No, I don't care about the row is not going to change, right? It's always this row, always 0. This row is never going to change. I'm at this row. I'm only looking at the words and the characters to the right. So only thing that's going to change for me is the column. This is the column I'm in, 2. I need to go all the way to 4. 2, I know that's the column that is passed in. What is 4? How do I get this 4?
Plus length of word minus 1.
No. Length of word is 3.
Yeah, column plus length of word minus 1.
Okay. Length of word minus 1. Why minus 1?
Because the list index is at 0, but the word length index is at 1. Like it starts at 1.
Okay, but remember the range? It doesn't include the last one, right? If I
Oh,
want,
yeah.
right? So I have to make, I'll just leave it like this. So these are things that you have to be very careful of. Okay, so let's make this a little bit more meaningful rather than I. Let's call this a column index. So I know exactly what I'm talking about. Okay, so now I have all the column index. I just need to do puzzle word append, right? Puzzle. I have the row. That's never going to change. So here the column index, we already calculated it, right? So if I do this, now my puzzle word will exactly contain all these things that matches the word length, right? So I just need to return the puzzle word. Does that make sense? Is everybody clear on how we got those indexes? We have to think before we try to implement this method, what are we trying to solve? I'm here, somewhere I'm here, right? Doesn't matter what character I am here. I don't care about the row, that's never going to change. I'm only looking for the word to the right. All I need to know, make sure is that I have enough space to the right, which I already checked, right, using my other method. So now I don't care, I just need to go all the way such that it has to match exactly the word's width, right? So column plus column plus word width, right? Length of the word. What if I take this column out? What is that telling me? Does that work?
No.
No, right? Length of the word is 2, or sorry, 3. That'll just go up to here, right? I'm at column 2. If I say column 2 to word, length is 3, and 3 is not included. The second argument is excluded from the range. So I will just only pick up this character only. I won't, right? So you have to be careful. So always try to try to get an example and try to pass those values, like pretend that you're passing those values and making sure it's actually doing what you think it's gonna do, right? Make sense? Okay, so before you start writing anything, you have to think, what am I trying to do? Okay, so right now I have the characters to the right. Okay, so that's puzzle word. Now all I have to do here is, if puzzle word is the same as word, right? Puzzle word right now is a list of characters, right? List of characters, and so is the word. Remember, we read it from the file. Reading from the file, every line is a list of characters, right? So then I can compare each of them like this, because they're the same type, list of characters. So if this is true, then I can just print out I found the word, right? So how do I print that word? What am I looking for? So we say the word. So the puzzle or word, doesn't matter what it is, word. But I can't just print the word because word right now is a list, right? So I need to make it into a string. Okay. So word exist right from, I need to give the coordinates, right? So I can just say row column. Okay, so I'm creating a tuple row column, because when I print the tuple, it's going to put the bracket automatically. All right. So if word can fit to the right, get the characters. If puzzle equal to word, I print this. Okay, so let's run this, see if it actually works. Let's keep our fingers crossed. Oh, we haven't printed it. Oh yeah, let's just call this, I think I call this, yeah, it doesn't matter, let's just run this. All right. Oh, string word. Oh, sorry, it's not string. I need to join it. I need to join the word. Okay, so it did find, it is finding it, but it is printing in this list way. I just need to join each of the characters in the, okay. Okay, so it found the two words to the right, polo and snooker. Okay, so that is basically our, you can call it a shell. Okay, so we have a way to check for the right, and we have the way to get the word from the puzzle and check our word, see if it's the same, then we print we found it, right? And we have the coordinates. Okay, so now with this structure in place, how can we check for the, let's say, for left? What would we do? Pretty much it's like almost like the hard part is already done. Okay, all we have to
You
check.
could
So we if we go back to the puzzle, we need to check in all 8 directions, right? So we already did this direction. All we have to do now is check for the other directions, right? That's all we have to do. So anybody wants to take a look take a stab at the left?
just do the opposite. So you do
So in terms of the functions, okay, let's write the functions first. Okay, so it's going to mimic something that we have already done, right? We already did can word fit to the right. If we want to do for the left, what functions do we need? Just name them. Can word fit
If it
to
can
Column.
fit to
if
left,
it can fit, and the characters.
right? And get characters to the left.
Yeah.
Okay, so let's always think at the higher level conceptually, right? Then we can fill in the rest. Okay, don't go all the way to the very all the very nitty gritty detail. Let's think about higher level, how we are breaking this problem. Okay, so we already broke it in a way that such that we can get to the right, right? I mean, check to the right. If it's enough space, then we get the word. Okay, all we have to do here is we just have to repeat that for again and again. If can word fit to the left, right? Okay, what do we need to pass in if we want to find if the word can fit to the left? Obviously the word,
Word,
what else?
column,
Column and the width, right?
but
Do I
yeah.
need to pass the width?
No.
No, right? Why no?
Because you're gonna go backwards.
Yeah, I'm gonna go backwards,
Or back.
right? So
Yeah.
so I just need the word and the column. So I need the word, column. Why I don't need the width? If I'm going backwards, but why? Why do I not need the width?
because you can use the column position to figure out if you can read it backwards.
Exactly. So column position would already tell me, if we go back to our diagram, column position would already tell me, this is 2. Column position will tell me I have, okay, 2 means I have 3 characters, right? And I have a -3. So how can I write this formula here? Can word fit to the left? So the remaining, if you want to copy this thing here, remaining, how many remaining? It's, how do I calculate how many remaining? Krishna, want to take a stab at it? How many characters? So if I'm at position here, column here, how can I know how many characters do I have to the left, including this one? Come on, guys. This is 2. I'm already telling you I'm at position 2.
Column column plus 1 is if column plus 1 is equal to length of word.
Yeah, or less than, right? So if I say remaining is what? Column plus 1. That's how many characters I have to the left. Okay, if I'm going like this. Now I just need to say return length of the word, same thing. If the length of the word is less than or equal to remaining, I know my word can fit. Same thing, right? I'm just trying to find what's remaining from my position. First, this one was to the right, this one is to the left. Would this work? Yeah, right? Alright, so now I have a method, a function to check can the word fit to the left. How can I get the word? Let's copy paste this thing. Word to the left. I need to get the word, the puzzle characters to the left. All right. Now my starting is always column. So I'm starting here. I need to go backwards. Or I can find the position that I need to start from and come all the way to column plus 1, right? So let's do that. Let's find out what the starting position should be. So if I'm at column 2, what should the starting position be? If the word is 3, length is 3. Let's say 2 minus 3. What would that take me? That'll
Minus
go
1.
minus 1. So I don't really want that.
So you want column plus 1 minus
Yeah.
length of word.
So let's do that. So our starting position will be column plus 1 minus the length of the word, right? That'll give me the correct one. And here I will come to column plus 1 because remember column because the range does not include the last one, so I have to plus 1. So this way I should be good, right? Just to make sure that I am doing the right thing, I will just put the brackets around it so the brackets gets executed first. So column plus 1 would be 3. 3 minus 3 would give me 0, right? Because I need to start at 0, 1, 2. This is exactly what the length of that word should be, right? Does that make sense, Krishna? You are struggling with all the indexes. So this is how we have to find the indexes. Okay, we have to just think a little bit. So I am at column 2. I have an example. Always write an example. So then when you use the numbers to subtract or add, then you can figure out exactly, right? I'm at 2. I have 3 characters left. So if I take the 3 here, what do I need to do to get 0? I have to subtract obviously from this, right? Subtract the length. But if I subtract the length right now, 2 minus 3, it will go to minus 1. So I will have to adjust it such that I add 1 to it, then I subtract it, then I will end up with 0, right? So that my starting is fine, but my ending, I cannot just use the column because the range does not include the second, right? So I have to do a column plus 1. So my range ends at 3 rather than 2. Okay, so now if I have this, that's it. I don't need to do anything else. Pretty much have that function too, right? Characters to the left. So let's do the next one. Okay, so then I will say puzzle word get characters to the left. Puzzle, what do I need to pass? Row, column, and the word. So this will give me the puzzle word to the left. Now I just need to do the same thing here. The puzzle word, same as the word, then I say exist left from, right? So I need to do, so let's see, this should work, right? Let's run this. So I should be able to find all the words to the right and all the words to the left. It didn't find the words to the left. What are we doing wrong? Let's see. Can word fit to the left? Yes. If it is, puzzle word, get characters to the left, row column word, puzzle word equal to word, then we print. Alright, so something wrong with our, what did we do wrong? Can word fit to the left? Remaining. Length of the word is less than or equal to remaining. Okay, can word to the fit. Puzzle word, column index. I'm going to go from column, what? Oh,
You're looking for
this one.
the right one.
Yeah.
Yeah.
So what is this thing here? Okay. So I'm starting at column plus 1 minus length of the word. Column plus 1, 3 minus length of the word would give me 3 minus 3 is 0. Okay. All the way to the column +1. Column index, puzzle word, append puzzle word. Okay, if what are we doing wrong? Turn this. What am I doing wrong? Oh, column +1. Yeah, that's correct. Word. Okay, let's debug this, okay? All right, so I have my parser. What is my word right now? Word is football. Okay, so this is going to iterate through all the characters, right? So right now I'm at row 1, column 6, and we know that football, let's see, football exists below. Okay, so we don't care about that. So something to the left. Which one was to the left?
It's pool.
Sorry?
Pool. Second last one.
Polo? No.
No, pool. Second last one.
Second
Oh,
last.
pool. Okay. That's the only thing that is left? Is that the one?
There was only one.
Oh. Okay. This is going to take a long time. So let's come up with a different way. So I'm going to copy this word. Words to. And I'm only going to put pool. And I'm going to debug this thing. Give the puzzle. And I'm going to get the words.text. No, words2.text. Okay. So now, can word fit to the right? Where was pool? Pool was at 13, row 13. Okay, row 13, column 2, no. Okay, column 11, right? Row 13, column 11. All right, so let's see what's happening here. Can word fit to the right? I don't care about fitting to the right. I know it has to fit into the left. So word is pool, column What's the column? 11. Okay, so let's step inside. This is step into it. Okay, so if we step into it, all right, remaining is 12. Okay, 11 plus 1. So if we go into a puzzle, pool is here. Where is it?
It's the bottom, like the corner. The bottom corner. The other one.
Oh, here, pool. Okay. All right, so it's at the very end. So I have at P, I have 12. Okay, let's see. Yeah, this is with this 12, right? So okay, so length of the word is okay. This should tell me. Okay, so it should fit in there. Get characters to the left. Okay, so this must be the problem. So let's step in here. Okay, that's the, what is it, puzzle. Now I would come here. So I would start at column plus 1. Okay, words dot append L. Oh, I need to go left. Ah, that's why. So I shouldn't start from here. I should start from here. Right now I'm going to end up with loop. You see? So what we did is wrong. We should have started from here and go backwards. You know what I mean? Yeah. All right, so let's do that. So we need to go, or we can just do the reverse. So let's define the method to reverse. Which one is good? Let's do the proper way. So
Okay.
let's go. So obviously we need to this should be our ending one, right? This is give me 0, but I need to go -1 once more because the end one doesn't count. So I would just take out this plus. So that'll give me where I need to go. This will give me -1, right? Now I need to start at column, that's for sure. Now this is going backwards, right? So how can I go backwards in range? I just need to specify
-1.
this step, -1. All right, so if I do this, this should be good. So I'm starting at the column and going backwards, column minus length. I don't need to add the +1 because it has to be -1, right? Column, let's say that it's going back to our example here. So if I'm at here, I need to go all the way here. So that's 2 minus 3 would be -1, right? -1 doesn't get included. Only the one before that includes, right? So this way I'm good. All right. So now I think it's good. Let's run this. Run the program. Puzzle.text, words.text. Okay, now we got the pool to the left. Okay, so as you found out, it's always a painful when you're like, when something doesn't go wrong, something doesn't work the way that you expect, you need to go and debug, right? And you need to such that you need to adjust it such that you bring down the amount of stuff that you're debugging over. So what I did here is I change my word, right? I just put only one word so I don't have to go through all the words. So this is where unit testing comes in handy. Okay, so I've shown you guys how to do the unit test. It requires a little bit more effort, but it saves you from this pain whenever you end up with this situation where something doesn't work. It's always a pain. So how could we have avoided this? We could have simply wrote a test cases for all our methods, right? And had we done that, we would have caught that issue when we try to unit test this function. Then we wouldn't have gone into that bigger issue of trying to debug and all that. Okay, So that's something we have to look at, how to write the unit test cases. I know that Vaishna, she did it because she was having trouble and I showed her how to do it. Maybe we don't have enough time. Actually, you know what, let's show how she did it.
I don't think I've sent you.
You didn't send me? Oh, can you send
I
me
didn't
send me the
send you.
okay, we can have another lesson on how to do the unit test cases.
I submitted.
Okay. So these are the unit test cases that she wrote. Okay. Where is it? Here. Okay. So she had some functions. For example, where is it? Has enough characters to the left. Here it is. Has enough characters to the left. Okay. So she had a function called has enough characters to the left. So she's giving. So she remember the unit test case. So we always like have the expected value and the actual value that comes out of our function. We check if it's true, right? So she had column 2 and a word of AB, right? And she made sure that if she called her function, it will return true for this. So if column is 2, that means she's at the third position. So AB, which is only 2 characters length, it should fit, right? That's true. Oh, she didn't have a good good enough test case. She only had the positive cases, true, true, true. She should have had the false one as well, just to make sure that her function is behaving as it should. Okay, Vaishna, your unit test cases partially covering your function. It didn't cover the case when the word didn't fit. Okay.
Okay.
So
I only did true ones. I didn't do false.
you have to do the false ones too, just to make sure that your function is covering the negative cases too, right?
Okay.
Here you had characters to the left. Column 4, yes, it should cover. Even this one, 0, 1, 2, 3, 4, yes, it should cover. So it is working. But you should have covered for something that is like big like this, but the column should have like a 1 or 2 or something. Then it should return false. Okay. So Vairon Krishna, I remember the unit test cases we talked about. So we say like we import the unit test case and create this, and then write the functions in there. We check, right, whether something is returning some that is expected value. In this case, this function that is returning whether it's enough characters to the right, and this one is enough characters to the left, and this one, for example, let's say the other one, reading from the file. She wrote a test case for that too. So this is the expected words that she should get back. So she calls her get words function, passing the words.text. This should return back exactly what's expected here. Right? So rather than debugging your program, you write your test cases and run the test cases to make sure that your function is behaving the way that you expect it to behave. Okay, so if we had done all those unit test cases, then we wouldn't have come across this scenario where our function is like blowing up. Okay, or less chance of this happening. Does that make sense? So from now on, always write test cases. Okay. So I will ask Vaishna to send you guys the test cases that she wrote for her her wait. Okay. So now we have the structure. All we have to do is we just have to plug in the rest of the remaining directions, right? Something that we overlooked here is that for example, if let's say here, if we can fit the word to the right and if the word is there and if it matches, do I need to go through the rest of the characters in the puzzle? I don't, right? I should return here, or sorry, break from here. Same here. Once I find the word, I don't need to go, so I should break. So if I break out of it, the break statement only breaks out of the immediate for loop, right? In this case, I don't really need the column either. I need to go and check the next word. I don't really care about any of those. So I will just have something here, say breakout equal to false, and I'll just set the breakout. Okay, I'm just breaking it out. So then I can check at the end of this loop here, right? If breakout equal to true, I can just break here too. Okay, so this way, what's wrong here? Okay, if breakout. So if it is breakout, then I break out of this loop too, and I just check the next word. Okay, that's all I'm doing. I mean, there's nothing wrong with checking everything, but it's inefficient, right? As soon as you found the word, you just need to go to the next word. You don't need to go and check the rest of the characters in the puzzle. Does that make sense, Krishna? Yeah. So that's why I break out. Now I didn't have an if else here. What will happen if I had an if else? It'll check if the word fits to the right. If it is, even though it doesn't. Remember the if else. If that'll, like, whatever the first condition that gets satisfied, that's the block that is going to execute, and it won't execute the rest of the block, right? So if I had if else here, if elif here, that would mean if, let's say, for any character I see, if the starting character is same, and if so these two are related, right? So either one of these blocks will get executed, not both of them, right? So if this block gets executed, you wouldn't, but this one happens to be like the word doesn't match, right? So that means we didn't really find the word, but it will also make it such that this block won't get executed, right? So that's you guys see that we want to check every single word in all the directions, right? Not just only the right direction or whatever the direction that is satisfied. We want to check all the directions, and only if we find the word, then we should break out. So that's why I had it as if here. Okay, this is just one way of doing it. The solution that I'm like, if you go to the GitHub, the solution that I've done it like a while back, it's a little bit different. Okay, so I want you guys to go and look at that as well. Okay, but you can see how we can.
What happens if there was two words like that are the same? That are like, if there's two words that are same but different positions.
That doesn't matter as long as you find the first occurrence. But in a puzzle, it's not going to be like that. Nobody's going to give you, right? But you don't have to worry about that. But even if somebody gives that word again twice in the puzzle, we would just skip it, right? Once we find it, we'll go to the next word. You know what I mean? So even though there are two solutions, we don't care about listing all the solutions. As long as one of the solutions is there, it's okay. I didn't ask you guys to find all the solutions, and most of the time puzzles won't have like multiple solutions. In this case, in word search at least. Okay. Does that make sense? Okay, so you can go through the rest of them, right? You can see how we can do the rest of them. It's pretty simple. All you have to do is just write those pair of functions, right? Check to the let's say if we go to the bottom now, we can say check to the bottom if there's enough space to the bottom. If it is, get the characters in the puzzle that match this length of the word and see if it's the same. If it's the same, that's it, you found the word to the bottom. So you have those pairs of functions. Check enough characters. If it is, get the characters, right? You do that for all the other directions and then you're done. Then you would have solved that puzzle, right? So the tricky part here, like the remaining tricky part, is just making sure that you're getting those indexes right and you're iterating through the columns the way that we want. Like for sure, when we go upwards, again, we could run into the same problem that we had with going to the left, right? We didn't think through because right. So write the unit test case and you should be good. But you need to practice a lot, okay? You guys, the more practice that you have, the easier it becomes. Like for example, these indexes, when I look at it, I know where the indexes should be, what the length should be. Because right now it seems a little challenging to you guys when you see the index or where do I go? You know the where to go from where, but how would I get that, right? The length adjusted such that I have my two indices correct, so the range would be correct. So those things will come with practice. Okay, the more practice that you have, the easier it will become. But it's not hard. As long as you write the unit test cases and make sure your function works as exactly, then you won't have much headache. Okay. And I also want you guys to like make sure your functions mean what it's supposed to be doing. Just don't give random words and don't give like random words to these variables. Just name them as what it is. Like for example, here I named it column index, right? That's exactly what it is. If I just name it I don't know what I is. I could be anything, right? Those are the examples that I give you when I explain some feature of a for loop or something, because I don't know what I'm talking about that time. That I could be anything, right? But in this instance, it is column index is what it is, right? So name it such that when you go back and read it, it makes sense to you. Like for example, here I named it remaining. That's what it is depicting. Column minus plus one. It's going to tell me how many characters are remaining, right, from that position. So something like that, more meaningful, right? I also want to like go over. I want to use one of your programs that what you guys wrote, and I want to go over it and show you guys what kind of mistakes you guys are making, like when trying to like break it into smaller functions, right? Let's do that in the next class. So I don't know if you guys want another assignment right now. I have an assignment lined up, but I don't know if you guys are ready for it. Do you want do you guys want to go over the solutions so far we have done and look at it, right? Look through those and see how we break those problems, okay? Especially the indexes, how we get those indexes correct, right? It's just, I think there are some improvements that can be done, all of you. And Vaishnav, send the unit test case, okay? So it gives them an idea of how to do the unit test case. And if you are not sure something, just call each other, okay? You guys are not doing that much now. So call each other and discuss, okay? You guys are all working together. Okay. Yeah, more practice. We need to have more practice before we go to the next assignment. By the way, the next assignment is Connect 4. It's similar to tic-tac-toe, except you have more. So the same way, you just model it as an array. I'm sorry, a list of lists, right? Every position on the board is represented as an element in a list of a list. So I don't know, do you want to start this or do you guys want to go over the solutions?
Go over solutions.
Okay. Waylon, do you want to give it a shot at the Connect 4?
Yeah, I want to give it a shot.
All right. So tonight I will post a solution. Krishna, if you can go over the solutions. If you're comfortable, just take a stab at it. Okay. Vaishna, I think you're ready to give a shot at the Connect 4. Okay. It's Connect 4 is it's nothing complex. Okay. But you guys have already done the basics of how to search like all these diagonal, because Connect 4 is all about like finding something in like left, right, bottom, up, or diagonal, right? Anything that is like matching four of those squares, right? Or discs. So you have already done everything that you guys need to do. Like you can basically you just so basically if you had an array, right, you just have to go through every one of them and see in any direction, just like the word search. In all those 8 directions, if you have 4 of the same color, then you know that person won, right? Just like searching here, you're basically, instead of multiple different kinds of word, you're just searching for a word that is like, red, 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 or yellow, 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 like 4 yellow or 4 red. That's all you're going to do. You see that? There's nothing different to it. So this is basically the same thing. So go over the solution, and I'll post the solution. I'll post the assignment for Connect 4, and you guys can go over the Connect 4. Okay. It shouldn't be hard. It's easy. You have already everything that if you have done this, if you have gone over the solution for this, you can do the Connect 4. It's easy. Okay. All right. So I'll post the assignment. Okay. Any questions? So for Connect 4, for sure, you have to write the unit test cases. Okay. That's going to help you guys from pain. Unit test cases are there to help you. Don't skip them. Okay. But there's an art to how do you write the unit test cases. So if you're not sure, like Vaishnav will send the file and you can look through it, how she's testing. And I've already given you guys unit test cases for the previous assignment, right? Remember one of the assignments I showed you guys, assignment 4, I think. Yeah. So basically you just write a bunch of test cases, okay, for each of your methods or each of your functions. Okay. And you should be good, but practice, okay? And take it as a challenge. There's nothing hard about this. It's just take your time and plan out a scenario, right? Like we did, draw it out, plug in the numbers, see if it makes sense, see if it gets the right answer that you're looking for. It's coming. If it's not, adjust the indexes. Okay. Just try to visualize your problem. You always have to visualize the problem before you start writing any code. Okay, if you just start typing code, you don't know what you're doing. So you always have to visualize your problem, exactly what you're doing, your algorithm, main idea. Okay. All right. So we'll see you guys next week. Okay. Any question? All right. Bye.
Bye.
Bye.